Okay, so we are building this Blynk sketch. We created our Blynk dashboard, and now what we're going to be doing is we're going to implement like this integration where we can communicate back and forth from our Blynk dashboard. All right, and so we've got our onConnected function. So we get hooked up, we get connected to the Blynk server. We get this kind of callback here saying we got connected, and then we're not really doing anything else. We have that Blynk run right there where we're checking to see if we're still connected, and this will like what this will do is if it's not, it will perform the run function, and if it got disconnected somehow, it's going to just let us know that it's disconnected, and this is handling kind of all the work. And so now we want to kind of integrate though what we have on our server end, our little dashboard where we can communicate back and forth between our Blynk dashboard and our device here. Okay, so let's pull up our Blynk dashboard. Okay, so here we have our device. You can see that it's online because it's connected currently, and we'll pull it up here. And so we've got these two inputs. If we go to our, let's see, device info. No, let's see. Let's get some information about our device here. We might need to go back to templates. So let's go to users. No. Sometimes I lose track of stuff here. Okay, here we go. My templates. And so we look at our templates, our data streams. So we have pin V0 and pin V1 that we want to interact with. Okay, and so pin V0 is like an output on our dashboard. It's connected to actually, no. Pin V0 is an input to our device, but an output from our dashboard. And then pin V1 is getting data from our device. Okay, so we're going to configure those things with V0 and V1 is how we're going to go ahead and take those data points. Okay, so the first thing we're going to do is we're going to write a function that will allow us to get data from our device. And so we're going to use this BLYNKWRITE function. Okay. And then what we do is we tell it which pin we're responding to. And so put V0, because that's our virtual pin. And for now, what we're going to do is we're going to get our data. And so we're going to say our value is going to be from this param type. And we're going to get the as int. Okay. And so if we look at this BLYNKWRITE right here, you can see what it expands to. BLYNKWRITE 2. And so basically, this is kind of the type of function definition here, or prototype, I guess. I wonder if we get more of this. No. And so basically, it's kind of like a wrapper for this function here. We don't need to get too much into it, but one of the arguments is this param type. And that param type is going to give us a lot of things here, but we can get let's see, the integer type from it. Let's see, add, begin, oh yeah, as int, so we can get it as an integer. We can also get it as a string, and then some other things here too. We don't really need to dig too much into this because this is really all we need. And for now, what we're going to do is we're going to say serial.print value. Now, one thing that I'm not sure about, I'm not sure what's going on under the surface of Blynk. Ideally, you want to avoid in a callback to have like code that's considered like blocking or takes a while. I don't know if that's happening here or not, if this is a callback or if it's like setting a flag or something. But we will probably want to try to avoid too much stuff like this. But for now, that's how we're going to handle it. And then we've got our LED pin set up. And then what we'll do is we're going to say digital write. And we're going to say LED pin, comma, value. And so we're actually going to control this LED based on that value. All right, and so now we've taken care of that BLYNKWRITE. Let's go ahead and test it and see if it works. And so we'll kind of do like a split screen here. And let's go to our devices, pull up our device. All right, it's building, we're connected. Let's go ahead and grab our serial monitor here. Okay, and so we're up connected. We're connected to Blynk. Okay, and so now we're going to try pressing this toggle. So you see I press it, and we got the 1 right here. I've got a little LED down here as well that turned on, and now it's off, and back on, and off, right? And you can see it's not perfectly instantaneous, but it's pretty quick. And so I'm controlling it from my dashboard. This is the device, the serial monitor from the device giving me that response. Okay, so we've got the LED integrated. The next thing we want to do is to integrate the button. Okay, and so what we're going to do there is we're going to add a virtualWrite function. And so we're going to say void button press callback. Or we'll just say interrupt handler. So we're going to configure this button as an interrupt. Okay, and in this we're going to just say Blynk dot virtualWrite, and then we're going to press put in V1 in this case. Pressed, and then yep. Actually, we'll call this a button change, and then we're going to do value, and then we're going to say digital read button pin, and then we're going to send this value. And so when it's pressed, we'll turn it on, and when it's unpressed, we'll turn it off. Okay? And so we might have to invert this. Okay, we'll see if that works. Now we need to attach the interrupt. Let me look that up real quick. So Arduino attach interrupt. Okay, so let's take a look here. This is what we want. And so we're going to put this right here. And so we're going to say attach interrupt, and then we use this function digital pin to interrupt, which I'm not sure if we need here because it's giving us an error. Let's put button pin right here. See if that solves it. Okay, yeah, that works. Okay. And then we're going to, instead of putting Blynk there, we're going to put our button change interrupt handler. And then here, where it says change, we can have it trigger on low, on rising, on falling, on high, on change. So we're going to choose change so we get it when it goes up and it goes down. So if we press the button, we're going to get our interrupt. And when we unpress it, we'll get an interrupt. So it's like serial.print. And we'll do it, just print the value when we press our button. Okay? And that should do the trick. We'll see if we made a mistake here. I don't know if this works with the ESP32 as well. I assume that it does, but we'll find out pretty quick. Okay, so we come back to our dashboard. Okay. And we got our code running. And so it still shows us connected even though it's in this kind of like boot state. I'm guessing it kind of checks for a connection every like minute or so. And so it'll read it connected even if it's disconnected after a bit. And now we should hopefully get a response here with button when the button's pressed or unpressed. And so that's what we want to see. And so let's go to our monitor. We're connected to Blynk. Okay, and so we can still control our LED, right? Now I'm going to try pressing the button. Oh, did not like that. Interesting. So remember what I said about, that's interesting, about interrupts. So the challenge here is that in an interrupt, we don't want to have blocking code. And so here we have some blocking code. And so we're getting something triggered called the watchdog timer, where it's losing access to the device, or like the processor's like freezing up because we're trying to do these two things. And so I'm guessing this Blynk virtualWrite takes a while because it's doing a call to their probably like a HTTP protocol. But what we're going to do here is we're going to make a new variable. So we'll say volatile button flag. Sorry, it should be int, actually bool, button flag. And this is what a variable we're going to set when our button value changes. And then we're going to say int value equals 0. We're going to make this volatile as well. And what this volatile keyword does is if we're changing the value of variable inside of an interrupt, sometimes when the code gets compiled and sent down to the device, the compiler doesn't know that we're changing these because it doesn't see a direct place where this function gets called necessarily. And so it will optimize these variables out, which means that we actually don't get a response from them. And so putting this volatile keyword there is like a flag to the compiler to say that don't optimize this out because we're going to be needing it. And what we'll do now is we're going to say if button flag, and even more so, let's do this. Let's get rid of this one. We don't need that one. Alright, and we're just going to take these two, actually these three, and we're going to put them in here, like that. And then what we'll do is we're going to set that button flag now to false. And then inside of our interrupt handler, we're going to set it to true. So button flag equals true. So what happens now is we register this interrupt handler. When the button gets pressed, it calls this function where we set our flag to true. And then later in our loop, we'll catch this pretty quick. When we see our button flag, we're going to go ahead and lower that flag, setting it to false. We're going to read the value on that pin, and we're going to write that value. Okay? And so let's see if this works. I think this will solve our problem. We were crashing it by doing too much in our interrupt handler here. And now we should be able to kind of get a response to the button there. And this is a way that you can get a quick response when that button's pressed and then do something with it down here without having to constantly be checking that button, because that's something that actually does take time and energy, and it's a lot more efficient just to check the flag here instead of pulling that button every time through the loop. Okay, so we're connected, got the time, connected to Blynk. Let's try pressing our button. So if I hold it down, and let go of it. So we're getting that light. So I'm holding the button down, I let go of it. Hold it down, let go. Hold it down, let go. So that works pretty well now. And we're in pretty good shape. So we got control over our button. We got control over our LED. And so now, really, the next step is to kind of think about, like, what are some things you could do with this? And there's other things that you can do too. So we can, if we want to go back to our, let's see, our developer zone, and we can go and take a look at our template, and we can edit our template, and we can add another data stream, virtual pin, range v3. Okay. Oh, V2 actually. So we'll pin V2. It's then min max 2 to 5. Okay. So this one we have a range of 250 values. So from 0 to 255, if you need to edit it, you can click on it. And so we're getting a range of integer values here from 0 to 255. You could also send a string. And then in our dashboard, we can add a slider here. We'll stretch it out like that. And we can edit this. We're going to connect it to that data stream range. Control stuff like that. Okay. Slider, we'll call it. Send values on release only. So we'll click save. So we got a slider in there now. All right, click save and apply. And so if you want to control like a range of values, and then let's also add one more here. It'll be like a range input. And so let's go with another data stream. And we'll call this one range display. All right, and we'll go to 0 to 255 for now. We could change that later. Okay, and that's pin V3. Okay, and then we're going to go to here, and we can make, so we have control. So these are the only ones we can use on our free plan. But we also have display, and we have a gauge. And so we can have a chart or a gauge. So we're gonna grab this gauge. All right, and we're gonna connect this one to range display. Yeah. Okay. And so we're going to, I think, on the next part, integrate our range display and our slider into our existing Blynk code.